becomes 0. Guys, this is the load diagram for this question. Everybody is good with it?
Yes, sir.
Okay. BM diagram, I have not done beyond this. The BM diagram for this, I am sure all of you know. The area of this one is 5 into 20, 100, 100, 100, and 100. So if you make the SF table, I can quickly take you through this question. SF table, no extra point required. Same points are good enough. SF will be in tons. 1, 2, 3, 4, 5. A, B, C, D, E. By areas under load diagram, you write here. It's 0, minus 100. So minus 100, minus 100, plus 100, 0, 0, plus 100, plus 100, plus 100, minus 100, 0. And the SF diagram then would be like this. You take the points A, under B I have B, C, D, and E. I take plus 100 shearing force, I take minus 100 shearing force. And since I'm adding the areas under horizontal lines, area is changing at a uniform rate. So the shearing force diagram shall comprise of slanting straight lines. At B, it is minus 100. So from A, it will go slanting to minus 100. Then through 0, it will go to plus 100 like this. So if C was not taken, still it will go like this and 0. Guys, is the SF diagram happy? Everybody's happy? It comprises of straight lines, right?
Yes, sir.
Okay. Then we make the BM table. We already have C point taken, so no new point required. C point is already under our consideration. 1, 2, 3, 4, 5. A, B, C, D, E. BM units will be ton meter. 0. Then it is minus this triangle, minus 1 by 2 into 20. Each is 20. So 10 into 100 minus 1000. Yes or no? Is it minus 1000? Am I right, guys?
Yes,
Area
sir.
of the triangle?
Yes, sir.
This triangle, right? Then minus 1000, another minus 1000 becomes minus 2000. Minus 2000 plus 1000 becomes minus 1000. And minus 1000 plus 1000 becomes 0. Now we have the BM diagram. Now this is where I was trying to tell our friend Ram also that we have only minus. So A, it is like this. So A, B, C, D, and E. Let's say this is 1000. This is 2000 then. So at A, it is 0. Let me change to red marker or green marker rather. A, it is 0. B, it is minus 1000. C, it is minus 2000. D, it is 1000. And E, it is 1000. These are the points. First triangle, we are integrating from vertex to base. So it's little bit, it will be like this going, right? This needs little more sharper, then it becomes steep. Okay, then it basically, okay, it becomes steep here. So it will not, okay. So it will continue like this, steep. So it will be steep like this, right, beta? Am I right? No, okay, it will become horizontal. So my mistake, sorry, beta. It will become like this, little shape round here and like this. Sorry, my mistake. Why it is rounding off here? Why it is a smooth curve here is because of this, because it is becoming 0 and then the rate is becoming less here and less here. So this part is flattened. So let me just use another color to overlay my correct figure over it. Let me just use another color to overlay the correct figure. This red one is the correct figure, guys. if there is any confusion in what I drew up here. Is that clear, beta? Ram, is that clear? This is the better shape, beta.
Yes, sir.
Okay. Why this is horizontal? This is because of this, because here it is becoming nearly zero from this side also, and then it is first nearly zero and then picks up. So that's why it is coming like this. So this is question number 2. We have done, beta. Okay.
Sir, while joining this curve, no, manually we can do, or by this this divider or something else?
No, you have to do it. It has to be a freehand curve, beta. Wherever straight lines you'll use scale, rest has to be freehand. You will not be able to use any tools, right?
Okay, then sometime it will become not so curve.
Beta, that will, the more you practice, better it will be. That's the only answer I can give it at this point, na? But by and large, the curve should be okay, na? Right?
Yes, sir. So
you compare. No, what I'm trying to say, beta, you compare my red curve and with what Ram has sent, you'll feel what the difference I'm talking. I'm not talking about the neatness part of it. I'm talking about the difference in the shape that I'm talking about. Okay.
Yes, sir.
So that is what I'm talking about.
Slightly up and down difference is okay, no, sir? Because freehand will be not.
Beta, next time, if I draw it next time, I'll also not be able to draw the same as the red one this time.
Yes, sir.
My own curve will not be the same on 2 different occasions, right? So let's not worry about beyond a point, right? So little variance will always be there, correct?
Okay, thank you.
Sir, please share last page, sir.
So you have not done this question, beta. What, any doubts here? Beta, any doubts? Let me know if you have any concerns. You should not be needing this page, but if you have any concerns, let me know. Done, beta? Okay. Guys, if you have any doubts on the load diagram, SF, BM, let me know of this simple case. And if you see, out of whatever questions I've shared, 70% of them are on the same concept. So there is a high probability that the question will be on same lines. High probability. I'm not saying that it cannot change. But if you see more and more tendencies for these questions, unless somebody is after you to basically spoil your day. Okay, that will hedge in the coming discussion then. Guys, I'll just read the questions quickly, and if anybody has any doubt, I'll then answer that. Otherwise, we'll keep jumping the questions. A box-shaped vessel 50 by 12 is divided into 4 compartments. So each will be 12.5 meters. The vessel is loaded with homogeneous cargo level stored as follows: 1 and 4 equal, 3 and 4 equal, 2 and 3 equal, 1 and 4 equal. Vessel then floats in sea water at a draft of 4 meters. Even keel draft of 4 meters. Draw the SF and BM diagrams of this vessel. How does this vessel differ from what we have done? In this question, he has not given you the light ship displacement, right? That's the only difference. Rest everything, this question you have already done. So how will you get the light ship displacement? You'll get the load displacement for the draft. That means our load displacement will be length into breadth into draft into density of seawater, whatever it comes to.
Draft 3
meters. Okay, make it 3. No problem. Make it 3 meters. No problem, beta. Cargo weight, you add all the weights. It will be 125 plus 125 plus 180 plus 180, whatever it comes. I'm not giving the answer. It's okay. The difference between the two will be the light displacement, right? And this is how you'll get the light displacement. That step will have to. You'll start with the getting of the light displacement. Then light displacement is stored, spread evenly. And then the question becomes like the ones we have already discussed. Anybody thinks he'll have a problem in this question, beta? So how does it differ from the previous 2 questions that we have done? In the previous 2 questions, the light displacement was given up front in the question. In this case, the light displacement is not given, but the weight of the cargo is given and the draft of the ship is given together with the density of the water in which he is floating. And by law of flotation, you can get the light displacement and then proceed with the question. Clear, bete? Anybody has any doubts on question number 3? Tell me, guys.
No, sir.
Okay. So that means light displacement will have to be calculated. So idea of reading through these questions is that these variations don't catch you by surprise. Okay. Question. Okay. Now we come to the next part of it. Okay. Guys, so far we have done the questions in which the cargo hold, whether 1, 2, 3, whatever, doesn't make a difference. In these, the cargo was stored level. Okay. Let us say we said it is 200 tons over 20 meters. And so length of the hold is, let us say, 20 meters. Cargo is 200 tons. Okay. When I asked you a question in making the load table, I didn't want the confusion that time, but now little discussion is required, clarity is required. If I say what is the weight of the cargo at point X per unit length, so what I'm asking you is cargo weight in tons per meter at point X. How much is that, guys? How much is the cargo weight per unit length at X?
10 tons.
10 tons per meter. Very good. What does it mean? Here you accepted it because it was level stored. You didn't challenge it. But what does it mean? X is a point. Is the cargo at X 10 tons? No. Does the length of point X is 10 meters? No. 1 meter? No. So neither X spans over 1 meter, that is per meter, nor is the weight of the cargo at X 10 tons. Then what does this 10 ton per meter mean is what you need to understand before we bring in the next type of questions, guys. Guys, this is something like your instantaneous speed. When somebody asks you the speed and you say 60 kilometers per hour from the speedometer of your car or bike, what does it mean? That when I asked you the speed, did we wait for 1 hour? No. Did we cover 60 kilometers? No. What does it mean? That if whatever was the speed at that point when I asked you, if the same speed is maintained for 1 hour, then you will end up covering 60 kilometers. Am I right, Vite? Does it mean that, yes or no? That whatever was the speed of the vehicle at the time when I asked you, if that speed was maintained consistently for next 1 hour, the distance covered would be 60 kilometers. That is what 60 kilometers per hour mean. Yes or no? Guys, do you agree?
Yes, sir.
Guys, do you agree? Okay. So that is instantaneous speed. That was a speed at an instant. Neither it was over 1 hour, nor was the distance covered 60 kilometers. It only meant that whatever speed at that instant was, if that is maintained for 1 hour, the distance covered would be 60 kilometers per hour. Now, if you look at this diagram that I have drawn, what does the weight of the cargo per unit length cargo will depend upon? The weight of the cargo will depend in the hold or at any point will depend on what? It will depend on basically the volume of the cargo. The volume of the cargo in turn will depend on the length of the cargo, breadth of the cargo, and height of the cargo, together with the density of the cargo. So that means the weight in the compartment which we are talking about at any point is going to depend on length. How much length are you taking into consideration? What is the breadth of the compartment? What is the height of the cargo? And what is the density of the cargo? Or the stowage factor of the cargo, you can say whatever it is. Stowage factor, okay, let's call it stowage factor instead of density. When we say that now the weight of the cargo per unit length will depend upon these things. So what does it actually mean? It means that it depends on length of the cargo, it depends on the breadth of the cargo, and it depends on height of the cargo, and it depends on the stowage factor. Now, once the cargo is known, whatever the cargo is, stowage factor gets fixed depending on the cargo. When I'm saying what is the weight of the cargo in tons per meter, then out of LBH, which thing is frozen, guys? You're asking per meter. That means you're talking of weight over 1 meter. Yes or no, beta? Correct. What is the breadth? Breadth is the breadth of the compartment. So that also does not change. What makes the difference if it was 20 tons per meter here and it was 40 tons per meter here? Between the two, which parameter is different? The parameter which is different is the height of the cargo. Yes or no, beta? Between the two holds, what is different? Same cargo, same stowage factor. Same vessel, same breadth. Okay, then length, if I take same length for both, length is same. Then what is it that is different between the two compartments? Do you agree that the parameter which is changing is the height of the cargo? Yes or no? Guys, tell me.
Yes, sir. Only height change.
So that means when I say what is the weight of the cargo at a particular point in that location, it is basically directly dependent on the height. So what does it actually mean when I say weight in tons per meter at X? It means that if whatever is the height at X, it continues for a length of 1 meter, the weight of this cargo in that volume, of course the entire breadth, the weight of that cargo will be the weight in tons per meter. Like I said, if the same speed continues for 1 hour, you will cover a distance of 60 kilometers if you said 60 kilometers per hour. Now here the varying factor is not the speed, the varying factor is the height. So if the same height of the cargo continues for 1 meter length, then the weight of the cargo then contained in that volume shall be 10 tons at X and maybe 40 tons at point Y. Have you understood what I have just said, beta? Have you understood what I said, beta? I said weight of the cargo at X in tons per meter or per unit length is equal to weight of cargo that shall be contained in volume with length 1 meter, breadth of the ship, and height is equal to height at X. If this is the volume of the cargo taken, that means because length 1 meter is fixed every time you say when per meter, they're like it was per hour in speed 60 kilometers per hour. So 1 hour was fixed here. So per meter length 1 meter is fixed. Breadth is fixed for the ship. Then the only factor that is varying is the height. So whatever is the varying factor, if that is same as at that point for that length that is required 1 meter in this case, the weight of the cargo then would be 10 tons per meter or 20 tons per meter as the case be. I will clear the screen, make the diagrams again, and then ask you the questions and answer your doubts. What am I saying? Let me first explain once again. If this was the compartment in which the weight of this is the height, that means in this, if I'm interested in weight of the cargo per unit length at X, that means whatever is the height of the cargo at X, whatever is the height of the cargo at X is there. If the same height continues over a length of 1 meter, right? This length is 1 meter. This is the breadth of the hold. So whatever is the volume contained in this volume divided by stowage factor will be weight in tons per meter at X. Have you understood what I'm trying to say, beta? Yes or no? Guys, please ask your questions before we make the cargo slopey. This should be sorted out with trimmed level first.
One more time, sir.
You're asking something, beta?
Sir, please repeat this one more time, sir.
No, you tell me. You repeat. I'll back you up. Don't worry. What do you understand by when I'll ask you the questions? What do you understand by the weight of cargo per unit length at X? What do you understand from our discussion? Whatever you understood, tell me, right or wrong. No problem. Is the weight of the cargo that will be contained in the volume whose length is 1 meter, breadth is the breadth of the ship, and height is equal to height of the cargo at X. So this, when you multiply these, you get this volume, yes or no, beta?
Yes, sir.
And this volume, when you divide by stowage factor, will give you the weight of that cargo, yes or no?
Yes, sir.
This will be the weight in tons per meter at X. Otherwise, X is the point.
Yes, sir.
Somebody will say, why are you saying per meter when X does not have a length? X is the point. But what do we mean by that? That whatever is the height at that point, if that height was to continue for 1 meter, the weight of the cargo shall be the weight per unit length at X. Guys, let me know if there is still something you want to discuss more on it.
Okay, thank you.
Okay. Anybody else, beta? So now, in questions that will follow, the cargo shall not be any more trimmed. Maybe the cargo is like this. If this is the cargo surface, then at X, this will be the height of the cargo. At Y, this may be the height of the cargo. At Z, this may be the height of the cargo. So if I have to get the weight of cargo per unit length at X, then it will be height at X multiplied by 1 meter length multiplied by the breadth. This will be the volume of the cargo divided by stowage factor will give me weight in tons per meter at X. Understood, beta? Exactly the same way as we are getting. Only thing is, when it was trimmed level, you were very conveniently, you accepted what I said. It is 20 tons per meter because you divided and you accepted it. But when it is sloping, you will, if I straight away go to sloping and start talking about it, you'll have a confusion. So first, let's put this issue to rest. Once it is done, the question is done then it's not bothering me much. Guys, in a sloping cargo, how we will find the weight of the cargo per unit length at any point, is that clear? It is the height that will be the deciding factor, right? Am I clear, guys? Please confirm.
Yes, sir.
Okay, so now we go to the next set of questions. Okay, here is the question. A box-shaped vessel 30 by 8 meters floats in sea water with iron ore. So you have a 30 meter long, 8 meter wide. Floats in the sea water, so sea water, with ore of stowage factor 0.67 cubic meters per ton, stored to a height of 4 meters at mid length. So it is stored to a height of 4 meters at mid length and sloping uniformly to 0 at the ends. That means we are seeing the side elevation of this vessel, beta. This is how the cargo is. This is the cargo. The vessel then floats in fresh water. Okay. It floats earlier in seawater, never mind. But now it floats in fresh water. So now finally what is giving is in fresh water. The vessel then floats in fresh water at an even keel draft of 4 meters. So 4 meters will be in line with this. WL, this is a freshwater draft of 4 meters. Draw the SFBM diagram of the question. Guys, is the diagram clear or any questions on the diagram first before we start talking about the solution? Please read the question. And do you agree with the diagram based on whatever is given in the question? If you have anything to discuss on the diagram, please let me know. Or are you good with the diagram? Guys, are you good with the diagram? Read the question related to the diagram. Let me know if there is any question pertaining to diagram. First step is diagram. Once that is done, then we proceed further. Bolo bhai logo, all good?
Yes, sir. Perfect.
Okay. Guys, we know what all we need. We need light displacement. We need to know how the light displacement is distributed. We need to know the cargo. And we need to know the buoyancy. Okay. Now, first and foremost, guys, light displacement is not given. But we have enough information in the question by which we can get the load displacement. Please speak up. How will we get the load displacement? What to multiply with what? 30 into 8 into 4 is the underwater volume. It is in fresh water, so many tons. Can you please multiply, use your calculator and give me what is the load displacement?
960.
960. If anybody is not aligned with any of the steps, interject then only, beta. Please ask that time itself. Then we have to find the weight of the cargo. Weight of the cargo will be volume of the cargo upon stowage factor. Volume of this cargo is what you're seeing is from the side. And what I'm doing, you don't have to do that. This cargo is like this to the breadth, right? So it is like this up, the full breadth. So if we take the area of this triangle and multiply by the breadth, I'm sure you'll agree, it will become the volume of the cargo. What is the area of this triangle which is facing you? It is half. What is the base? 30 meters. What is the height? 4 meters. This is the area of the triangle. Multiplied by the breadth, 8 meters, becomes the volume of the cargo divided by stowage factor given as 0.67 gives you the weight of the cargo. How many tons does it come? And if anybody has any question, let me know. You will just finish off in one line like this, talking to yourself, and finish off like this, but no explanation required, okay? Because we are doing SFBM, we can't take 10 minutes to explain how the cargo weight is calculated, okay? Well, in the exam, of course, in the class, if you have a doubt, please let me know. How much is the weight of the cargo, guys?
$716.4.
716.4 tons. Anybody has any questions on weight of cargo, please let me know. If none, this will give us the light displacement, the difference between the two. So it will be 0.6, then 9.3, then 5.4, and then 2. 243.6 tons is the light displacement. Am I right, guys?
Yes,
and
sir.
In the assuming it to be uniformly distributed, please divide by 30 and give me how much would it be tons per meter.
8.12.
8.12 tons per meter is the light displacement. Guys, any questions up to this point?
But it's not a whole figure, then we can convert to that Newton here also, 8.12, or is it?
If you multiply, it will not convert, no? But then what will happen to your light displacement and everything, no? Then you'll have to convert displacement, everything, 960 and everything will go into fractions, no?
Yes, sir, yes, sir.
It is the light displacement which has come per unit length. It has come awkward, no? Otherwise, it's okay, no?
Yes, sir.
So decimals will still come because 960 will go into fractions then. Okay.
Okay.
So for ship-shaped, box-shaped vessel, don't think of Newton, kilonewton. Stick to tons only, beta. Okay. Don't even consider that way, right? Okay.
Okay.
Now, guys, we are good to make the load table. Now look at the diagram with a very free mind and see, using your instinct and common sense, because we have done enough questions on beam. How many things, minimum points, you think we need to have the load diagram made? Look at the diagram and tell me.
3, sir.
Everybody agrees because there is something happening at the midpoint. Yes or no? Yes or no?
3 points.
You're absolutely right. We take these 3 points for the load table. Minimum 3, yes. And now we will make the load table. Okay. For 3 points, we'll make the load table. We'll make the load diagram on this page, and then I'll go to the next one. Okay. So that we can do the SFP and complete it. A, B, C. First, we have the light displacement. We divide A into 2, C into 2, 0, 8.12, 8.12, 8.12, 0. No change from what we learned. Okay. Before we go there, here, come here also. Guys, tell me, what is the weight of the cargo in tons per meter at A? What will be the weight of the cargo at A in tons per meter? What is the height of the cargo at A? What is the height of the cargo at A, guys?
0.
0. So if you continue the height of 0 for 1 meter, the cargo will be 0. What is the cargo weight in tons per meter at B? And this will also be the weight at C, right? And plus weight at C, right? A and C will be same. So I don't want to write again. Okay. Cargo weight at B will be equal to the weight of the cargo if the height of the cargo continues to be 4 meters for 1 meter. So 1 meter length, 4 meters height, 8 meters breadth of the ship or hold. This is the volume of the cargo, divided by stowage factor 0.67. How much is the weight of the cargo per unit length at B, beta? How much is the weight of the cargo per unit length at B?
$47.76.
47.76. We can round off everything to 1 decimal place also, but there may be some residual at the end which will be rounding off over error. But if you continue like this, there'll be no spillover. Okay. Guys, any questions on cargo weight at B? If anybody has any, this is the new thing we have introduced today. So that is the thing you have to focus upon. Rest everything is same. Next, we fill up the cargo here. Tons per meter, tons per meter. No need to divide A into 2 because it's 0 in any case. C is also 0. At B, it is 47.76. This gives us the total weight in tons per meter. 2 cells are divided. We divide the 2 cells. It will be 0, 8.12. This will be 8, 8, 55.88. And this will be 8.12 and 0. Since it's downward weight, we'll suffix with a negative sign here as we had done the other day. Next will be buoyancy. Now, since the vessel is floating at even keel, the buoyancy will be equal to displacement. Buoyancy will be equal to displacement. And what is the displacement? Displacement is 960 tons. So 960 tons is the buoyancy. Since it's box shaped on even keel, so it will be divided by 30. So 32. It will be 32 tons per meter. Okay. So now we have buoyancy in tons per meter. We divide the first and the last one into 2. 0, 32, 32, 32, 0. We suffix with a plus sign as done the other day. And this gives us the load at the 3 points, tons per meter. We divide the cells which are divided. 0 and 0, 0. 32 minus this is 8, 8. And 31, 23.88. This will be 88. And this will be 23 again. So this was plus here. Sorry, I forgot to put the sign. This will be minus here. This will be plus 23.88. And this will be 0. Do you agree with these load calculations, Peter?
Yes, sir.
Okay. Now we will make the load diagram. We'll make the load diagram. We have plus 23 minus 23. So we'll have it on both the sides equal thing. So we have A, we have B, and we have C. Okay, we have plus 23.88. Same distance I can take on the other side. Don't worry about the scale here, minus 23.88. In such questions, you don't have to worry about the scale if the values are same. Only two values have to be plotted. Okay. So whatever distance you take for plus, the same distance you take for the minus, and finish it off. Don't unnecessarily get into 1 centimeter so much and all that. It's not required. So it is going from 0 to plus 23.8. Then it comes to minus 23.8 at B and comes to plus 23.8 here, and then comes to 0 here. Guys, what is load resultant of? Load is resultant of light displacement of the ship. Light displacement has been assumed to be uniformly distributed. So light displacement curve will be horizontal. Then it is the resultant, it includes the buoyancy. In this case, the buoyancy is uniformly distributed, so buoyancy curve is also horizontal. Then it includes the weight of the cargo. The weight of the cargo is slanting straight line, sloping straight line. So if you take the resultant of 3, 2 of them are horizontal lines. The third is a slanting line. The resultant will be a slanting straight line. Do you agree with me, beta? Yes or no? And that slant is coming because of the slant of the cargo. Right, guys? Yes or no? Do you understand the logic I have given when I'll be joining them with straight line rather than just saying join them with straight line? But why are we joining them with straight line is because this load is the resultant of 3 forces. Out of 3, 2 are uniform. Third is changing at a uniform rate. So the resultant will change at a uniform rate. Yes or no, beta? Am I right? Correct? Guys, have you understood that what I have said, or you have any clarifications to seek? Okay. So that means from plus 23.88 to minus 23.88 will join with a straight line. It's a straight line with a scale, guys. Likewise, we'll join this one with a straight line, and this becomes my load diagram. What do we see in this case? The load diagram is crossing at 2 points, and so these will have to be taken for the SF. My ship is 30 meters long, divide down into 4 parts. So each one of them will be 7.5 meters. Guys, load diagram is done. Are you okay with the load diagram? Then I'll go to the next sheet and continue with SFBM. If you have any questions to ask on the load diagram, please let me know.
So this buoyancy, we need to add the cargo weight also, sir.
We have added, no, these load values of 23.88, all the three have been taken into account, na bete?
Okay.
How did you come to the load, these values that you're plotting?
The weight of the ship is plus cargo weight.
And what is this in green here?
Buoyancy, okay.
You didn't do yesterday?
Yes,
Those
sir.
questions. So the buoyancy was not part of the load, beta. Okay. So now with this load diagram, we go to the next page and we then learn how to close out with SFBM. So here is the question figure for you, so that there is no miss out on it. Now, my load diagram is like this. Let me make a small load diagram thing here. Again, I'll just copy it as it is. A, B, and C. And we had it plus 23.88, minus 23.88. And then we joined them with a straight line. And so once you have got the load diagram, how to proceed after that is what I'm going to focus upon now. So this was the change is already done now. Rest everything is what we learned yesterday, right? Each one of these triangles has a base of 7.5 meters. I'm just cutting short on that beta. Now what do you see? My load diagram has 4 triangles. 1, 2, 3, 4. All the 4 triangles are exactly identical. What happened? Light is on, is it? Okay, it's come. Okay. Now all these 4 triangles are exactly identical. That means area 1 will be equal to area 2, will be equal to area 3, will be equal to area 4. And how much each area would be equal to? Half. Base will be 7.5. Height will be 23.88. Can you please calculate how much each area would be, beta?
89.55.
89.55 or 89.6, whatever you want to take, that's okay. Now we make the SF table. Obviously, beta, we have to take the 3 points A, B, C, and additionally the points where the load diagram is cutting the x-axis. So we have to include these 2 points more. So now we'll make the SF table for 5 points. And we'll keep repeating the areas. Now there will be no divisions, so it is one thing only. So 1, 2, 3, 4, and 5. Sequence will be A, then X. Be careful from the diagram, guys. B, Y, and C. This will be SF in tons. Area under the load diagram to the left of A is 0. To the left of X, the change is plus area of the triangle. That means plus 89.55. So it becomes plus 89.55. We carry forward plus 89.55. And then we have change taking place minus 89.55 becoming 0 at B. We carry forward 0 and then minus 89.55 becoming minus 89.55 at Y. We carry forward we carry forward this 89.55 this thing, we have plus 89.55 becoming 0. Does everybody agree with, does everybody agree with this, what I have said, beta? Guys, am I clear? Am I clear, beta?
Yes, sir.
Okay. Now we'll draw the SF diagram. So let's make the SF diagram here. We have minus and plus, same values, so we'll hold them like this. A, then X, then B, then Y, and then C. This will be SF in tons. Again, the same value, so there's no point in wasting time on the scale. If this represents plus 89.55, this will represent minus 89.55. This is the way you can do it quickly, guys. Then I plot these points first. I mark these values. At A, it is 0. Then it goes to plus 89.5 at X. Then it comes to 0 at B. It goes to minus 89.55 at Y and becomes 0 at C. Now, guys, tell me what will be the shape of the SF diagram? Look at the load diagram and tell me, will the shape of the SF diagram be straight line or curve? Tell me first that.
A straight line.
Look at the load diagram. You think SF will be straight line, beta?
Curve line.
Are you integrating areas under horizontal line? Why did you say they are straight line, beta? What made you think so?
Actually, I think, sir, uniform change. That's why.
In the load diagram, the area is changing uniform. Tell me, look at the load diagram.
No, sir. No, sir. Sorry, sir.
No, not. It's not. You don't have to say sorry to me. You have to make sure you don't make mistakes, beta, in the exam. By areas under the load diagram. You see the triangle, na, beta? Area is not changing uniformly. So now, from A to X, the triangle is being integrated from base to vertex, and then from vertex to base. So it will be first steep, like this. You see, if you want to see roughly, then midway here, this value should be about 3/4. You see, I told you that day also, no? Midway, the value will automatically, it will give you the shape. And then exactly the same thing, it will go on to the other side. Then the next triangle from B to Y is from base to vertex. So first it will remain steep, and then it will become horizontalish here. Same thing with a horizontal flip, and then it will close from here the same way. All these 4 quadrants are identical. So this value is here actually. Y is somewhere there. So if you see quadrant 1, 2, 3, and 4, they are all identical. Any aberration is a drawing error, beta. If they are not looking same, it's because of and I can't cancel it, because if I cancel, everything will have to be deleted. So basically all these 4 quadrants are identical. So your shearing force is a curve in this case. Understood, beta? Yes or no? Because the load diagram was slanting, shearing force is a curve. Anybody in the class has any questions on this, beta?
सर यही वाला है सर, जो अपन ने लोड डायग्राम लिया था उसको स्ट्रेट लाइन से जॉइन कर दिया था और इसको कर्व किया.
So how did you get the SF? How did you make the SF table?
लोड डायग्राम से.
By areas under load diagram, correct? So are the areas under the load diagram changing at uniform rate? No,
नहीं सर, SF का नहीं इशू है. SF तो ठीक है. लोड
हाँ.
डायग्राम में हमने कर्व क्यों नहीं किया सर? वो आपने बताया.
I explained that. load is a resultant of which all forces? Please speak out.
buoyancy और ship का जो है जो downward forces cargo
All
and
components. Speak out the components. Speak out all the components involved.
buoyancy, lightweight, and cargo weight.
Very good. In our question, is the lightweight changing or is it uniform? In our case, the light displacement of the ship is uniform or changing?
Uniform.
In this case, uniform. Is the buoyancy changing or uniform?
Uniform.
Is the cargo changing at a uniform rate or cargo is changing at a variable rate?
Uniform rate.
Because it's a slanting, right? Straight line, right? So if out of the three components, two components are uniform and the third is changing at a uniform rate, the resultant will also change at uniform rate, correct? Yes or no?
Yes.
So therefore it will be a straight line, correct?
Yes.
Okay, and from the straight slanting line, you get a curve for SF. Same thing, integrating from base to vertex or vertex to base. Is that clear, beta?
Yes, thank you.
Okay, now for BM, guys, same way. Guys, any questions up to SF? For BM, we will calculate here area A1 will be equal to area A2, will be equal to area A3, will be equal to area A4. And this area will calculate by Simpson's rule 1. This A2x is 7.5. If I take a middle ordinate, this will be 75%. I can take exact value actually, because I know it will be 75% of 89.55. Otherwise, if you read from here, you can read from here, doesn't make a difference. What will be 75% of 89.55 beta? 89.55 into 0.75, how much it comes?
67.163.
Okay, 67.163. Obviously, when you read from the graph, the best you can read is 67. Otherwise, somebody will read 65, somebody will read 70. Correct, beta? Yes or no? Am I right? This middle ordinate, you have to read from the graph, or you can, if you are thorough with it, you can get it as 75%, 67.163. Choice is yours. Okay, it will only slightly change the values. The shape of the SF BM diagram will not change, only the maximum value will change. That's all that will happen. So if you have to calculate this area by rule 1, Simpson's rule 1, coefficient is 1 by 3. Common interval is 7.5 by 2 because AX is 7.5. So common interval will be divided by 2 into SOP area. We can't make table and fill up pages now, beta. First ordinate is 0. So 0 into 1, multiplier is 1. Plus second ordinate is 67.1 into 4. Plus the third ordinate is 89.6 into 1. Can you get this area, how much it comes to, beta? And tell me what is the area. So that using those areas, we'll keep repeating and we'll make the BM table.
447.753.
447.753. So 0.8 tons. Can I make it like this, beta? 447.8 tons.
Yes.
Guys, any questions on calculation of area? Firstly, agree that area 1, 2, 3, 4 are all same, number 1. That is the first thing you need to settle with yourself. And secondly, you have to quickly calculate this area so that when we make the BM table, we can keep repeating these values, right? Like we repeated the values of the triangle in the previous, when we made the SF table.
Sir, sorry, sir. One more time, how we calculated this ordinates value, sir?
If you have to calculate this area by Simpson's rule 1, how will you calculate with 3 ordinates? Tell me.
Yes, sir. First ordinate will be 0.
And third ordinate?
Third ordinate will be 7.5.
7.5. That is 7.5 ordinate.
No, sorry. 7.5 जो वैल्यू आएगा सर मैं कैलकुलेट करें जैसे अभी 60 वो आया 67.163.
अबे x पे कितना है? What is the ordinate at x?
X पे सर 18.55.
ठीक है. अब now one you need is midway between the two, correct?
Yes, sir.
Okay. I said If you don't remember anything, just read from the graph and use it, right, beta? Correct?
Okay. Okay. Sir.
But when you'll read from the graph, you'll read 65, 70, whatever best you can read depending on the scale you have taken, correct? Yes or no? Correct?
Yes, sir.
But what I was trying to say was that basically, if you say this is point Z, what is the BM at SF at Z? SF at Z is this area. Yes or no? Look at this area is the SF at Z. Yes or no?
Yes,
Area
sir.
of this trapezium. And what did I tell you? That if this full triangle you take a midpoint, then the area is, this is 25% of the area. And this is 75% of the area. You remember, guys, this property I told you that day, property of a triangle, yes or no?
Yes, sir.
So if the full triangle area, if this full triangle area is 89.55, at middle point Z, the area will be 75% of it. Yes or no? Why? Because we are talking of the trapezium towards the base. Yes or no? So you can take it exactly 67.1 if you want. Otherwise, if you read from the graph, obviously it will depend on what you read from there, right?
Okay.
Okay. Now we will make the SF, we will make the, so now what I'll do is I'll retain this and I'm going to clear the page on top.
Sir,
so
sir,
that
sir,
I can,
sir.
yeah.
हाँ.
No, I'm
Sir-
just removing, don't worry, I'm removing only this bit.
नहीं वो नहीं, कुछ पूछना था सर आपसे. सर ये 0 into 1 plus 67.1 into 4 कैसे लिया सर यहाँ पे?
Arey, what are the multipliers of Simpson's rule 1 यार for
हाँ.
3 ordinates? 1, 4, 1.
भूल गए थे सर.
मैंने underline किया हुआ है ordinates को. 1, 4 and 1. I have underlined that for that matter.
आगे सर भूल नहीं कर गया था.
1,
ठीक है.
4, 1. Right, beta? And 1 by 3 is the coefficient. Common interval
Sir,
will be 7.5 by 2. Yes or no, guys? Am I right?
ठीक है सर.
Sir, if we take directly from the graph, that is okay. That will be.
Beta,
shortcut.
it is okay, but it will have lot of error. That will depend on the scale. If you, the way I have drawn it with a very small scale, taking it 89.55, if that small scale represents 90, then you can understand what will be the least count of your graph, hai na?
It will, that will be. on graph
Then
paper.
I don't think from this small scale you can read anything less than 10. Then you can only read 10, 20, 30, 40, 50, right?
Yes, sir.
Am I right, beta?
Yes, sir. Yes, sir.
So the accuracy will depend on the scale. See, if I'm taking shortcut to the extent that I've just taken a small distance as 8 to representing 90, then I should be able to pull it off. No, otherwise you should make a bigger scale graph so that you can read better from there, right?
Yes, sir.
Okay. So if you can't remember this property, you can rely on the graph, no issues. But as long as you can read good values from the graph, right?
Yes, sir. But in exam, no, they provide only one graph paper. So
No.
Any
What I'm saying,
individual-
why you have to do it on the graph? I said diagram. Graph is by mistake I used. I said diagram. I meant was diagram. You can make, if you make on the answer sheet, then you don't have to worry, na?
Yes, sir. Yes, sir.
And if they're giving you one graph, then all the calculations have to be on the answer sheet. Only the plotting has to be on the graph, right?
Yes, sir. Yes, sir.
Then you can't be doing these calculations there, na, beta?
Yes, sir. Yes, sir. So better to
So
do
then
on,
you'll have to take a call, beta. You'll have to take the best call that is possible, right? If you can remember these tips I have given you, that 75% and 25%, you can use them. If you don't remember, then at least attempt the question from the graph, whatever you can.
yes, sir.
So I will not say that graph is wrong, because you make a graph for this purpose only here. Okay, guys.
Yes.
Okay. Now, guys, I'll make the BM table here, small, chota sa, and then I'll draw the BM diagram on top. I've cleared that space. BM table by areas under SF diagram. Please write that. Guys, look at the SF diagram. Do I need to have any extra point for BM diagram, BM table? Please tell me yes or no. Do I need to take any extra point? Okay, BM will be ton meter. 1, 2, 3, 4, 5. 5 points. No, 1, 2, 3, 4, 5. Yeah. 2, 3, 4, 5. First A, then X, then B, then Y, then C. A 0, I carry forward 0. The change is area A1 plus. So plus is 447.8. So the BM at X will be plus 447.8. I carry forward 447.8. Another 447.8 gets added. It becomes 16, 1, 15, 1, 8, 1, 9, 895.6. I carry forward 895.6. There is a minus of 447.8, leaving with me plus 447.8. Plus 447.8 minus 447.8 makes it 0. That was the whole idea of calculating this area here was so that the table can be rapidly closed out. Okay. Now we come to BM diagram. Guys, the shape of the load diagram comes from the forces contributing to load. Shape of the SF diagram comes from the load diagram. And shape of the BM diagram will come from the shape of the SF diagram. Okay. So now we have all plus, plus, plus. There is no need to have anything below the x-axis. A, X, B, Y, and C. We have only two values to plot, so I can take one here and one there. They're double of each other. So this is how I can close it out fast without wasting time on the scale and everything, Plus 895.6. And now so they are exactly double of each other. So same spacing I use, whatever I take of a one, the same spacing I use for the other one. And then I have at A, it is 0. At B, at X, it is so much. At B, it is so much. At X, it is so much. At, Y and 0. Now guys, these have to be joined. Look at the SF diagram. Pay attention to what I'm saying. Look at the SF diagram. If this SF diagram, if I was to replace this curve with a triangle, if there's a if, I'm not saying replace it, please don't misunderstand me. I'm just giving you a tip. If in this diagram, if I was to replace the curve with a straight line, will this result into a triangle from vertex to base or base to vertex? From A to X,
So vertex to base.
it will become from vertex to base. So following the same thing, you just give the shape to this curve. Because initially the rate will be less and then the rate will be picking up as you reach X. So the curve from A to X would be like this. First the rate is less and then increasing. Then from X to B, first the rate is more, then the rate is nearing 0. So this continues and then it becomes like this. And just flip it horizontally and mirror image of it will come on the other side. And you'll have this as the BM diagram for this question. No need to do anything more. End of the story. Right here plus 895.6 plus 447.8 plus 447.8, and that's the end of the story. That's your question done. It's a MMD question done from end to end. What is the difference now taking place? One, whenever the cargo is sloping, it will result into a sloping straight line load diagram, resulting into SF, which will be a curve. And if SF is a curve, then BM cannot be straight in any case. That will also be a curve. If you have any questions to ask on what I said, please let me know, guys. I'll take you through the other questions And I would like to take one more question, whichever you want as we go along on this concept. But I'll read all the questions because like when we read the other question, we found that light displacement was not given. Some of you may struggle if you're not familiar with the variety that is being used. So the idea of reading through the questions would be to take you through the changes in the language and the information so that you are not stranded when it comes to execution. Okay, but I will definitely do one more question with greater participation from your side so that whatever we have done just now gets reinforced and closed. So up to 11:15 or so, I will take you through this, maybe do one more question. And 11:15, I'll take you to the last question of SFBM, that is where the vessel is trimmed. Though these questions never came earlier, but I don't know, in 2023 May, they used the question. And that question is genuinely not so straight to solve, especially the BM diagram. Up to SF, you still do it. BM is little tricky, but anyway, since it has come once, whatever best we can do, we'll try to do in that question also. Guys, as we read through the questions, if you have any doubts coming about this solution, let me know. We'll address them again if there is a problem. Okay. Read this. A homogeneous log of wood of RD 0.5, 12 meters in length and square cross section, 1 meter square cross section. Two uniform loads, 3 meter long and 1 meter broad, are placed on the log along its length, extending from 3 meters from each end. Log then floats at even keel draft of 0.8 in fresh water with its axis parallel to the water line. Draw the SFBM diagram of the logs stating their maximum value and the points along the beam where they occur. July 2012. Okay, I'll just make the diagram and explain the initial part. If you have any questions, I don't think there should be much, but if you still have, let me know. The diagram of this will be exactly the same way as the question that Ram had shared yesterday. And when I make, you'll realize here is the log of the wood. This is exactly the same question. Only thing is values are different, and instead of ship, it's the log. Here is the log of the wood. This is 1 meter by 1 meter cross section. Is it visible now, guys? Is it okay?
Yes, sir. Yes. Okay.
Okay. So this is the log I have made, 12 meters long. It says two uniform loads of 3 meters at each end. So that means you have uniform loads extending over 3 meters at each end. This is one, this is the other one, right? Breadth of the it does not make a difference, and placed on the log along its length, extending to 3 meters at each end. Log floats at even keel draft with these weights at 0.8 meters. So with all these, the log is floating at a draft of 0.8 meters in fresh water. Draw the SFBM diagram. Guys, if you see, the weight of the log will become the light displacement in this case. Yes or no, guys? Let's try to strike the equivalent. Weight of log will be light displacement. Yes or no, beta? Am I right? Please let me know if there's any challenge. Correct, beta? Does everybody agree? Will the weight of the log be light displacement? Yes or no?
Yes, sir.
Okay. The two UDLs at the ends, they are like cargo weight. Yes or no, beta? This 1 and 2, they are like the cargoes on the ship. Correct? If you see the question that I took today, what was it? It was a box-shaped vessel divided into 4 holds. You had cargo here and you had cargo here. Don't you think these two are exactly identical? Yes or no? If this cargo instead of here, this cargo is placed here, does it become the same? Yes or no?
Yes, sir.
Yes, sir. Yes.
Okay. So the shape of the diagram will be same as this one. Values will be different, of course. It had 2 holds empty, so 6 meters, there is no cargo. At the end, you have 1/4 cargo here. And so, Ram, whatever you have shared yesterday, except for the BM diagram shape, which has to be faired, the shape of the SF and BM of this question will be exactly the same as that one. Of course, the values of the two will be different. Anyway, let's see this question. This is the even keel condition, so it's not the type that we have taken actually. But let's say never mind. It's okay. So here is the other weight. This is the other weight. Okay, guys. The RD of the log is given. He says RD of the log is 0.5. So what is the weight of the log? Weight of the log will be volume of the log. Volume of the log will be 12 meters length, 1 meter breadth, 1 meter height. This is the volume of the log multiplied by density. 6 tons is the weight of the log. Do you agree with me? Yes or no? Correct, beta?
Yes, sir.
Yes.
Okay. And then we can find out at 0.8 in freshwater draft the load displacement of the load displacement of log. It will be the length of the log, underwater volume 12 into 1 into 0.8. This is the underwater volume multiplied by the density of the water 1. This gives you the load displacement. This is 9.6 tons. Am I right, guys? Load displacement of the log is 9.6 tons. Am I right by law of flotation, beta? Correct, guys? Beta, if you are able to understand and confirm, we'll be able to probably cover better the other things. I don't get to know whether you are understood or not, because at the end somebody will say why the load displacement was 9.6 then. Is 9.6 okay, beta?
Yes, sir.
Okay. The difference will give us the weight loaded. Weight loaded on the log, that will be 3.6 tons. That means that is 1.8 tons each, because there are 2 weights loaded. So 1.8 tons is loaded here and 1.8 ton is this. And since it's uniformly distributed, it is distributed at a rate of 0.6 tons per meter. This is 0.6 tons per meter. Am I right, beta? Yes or no?
Yes, sir.
Okay. So now you are good to do the question. Look at this diagram with an open mind and tell me, minimum how many points should we be picking up for the load diagram?
4.
4. I'm sure what 4 you meant was A, B, C, and D. Correct, beta? Yes or no?
Yes, sir.
Okay. So now we can make the load diagram for A, B, C, and D. And buoyancy will be 9.6. So buoyancy will be 9.6 tons divided by 12 at the rate of 0. How much? 9.6 by 12, beta? 8 tons? 0.8 tons, is it?
Yes, sir.
0.8 tons per meter, okay. So now, we'll have the light displacement. I'll quickly fill up the load values and leave the question there for you to complete. It's not the type that we have introduced today. So log weight or light displacement, whatever you want to call it, divide into 2, divide into 2. Log weight is 6 tons at the rate of 0.5 tons per meter. So 0, 0.5, 0.5, 0.5, 0.5 and 0. Cargo or weight loaded on top in tons per meter. At A, it has to be divided. At B, it has to be divided. At C, it has to be divided. At D, it has to be divided. At A, it is 0 to 0.6, then 0.6 to 0, 0 to 0.6, 0.6 to 0. This becomes total weight. In tons per meter, all the 4 will be divided. 0, 1.1, 1.1, 0. No, sorry, 0.5. This is 0, this is 1.1. Then this is 1.1, this is 0.5. This is 0.5, this is 1.1. This is 1.1, this is 0. This is 0. We put minus sign to it. And now we have the buoyancy. 0. Its buoyancy is 0.8. So 0.8, 0.8, 0.8, 0.8 and 0. Suffix with plus. And we get the loads. All the 4 will be divided into 2. And the load will be 0. This is plus 0.8 and minus this 1.1, so minus 0.3. This will be minus 0.3 plus 0.3 and plus 0.3 minus 0.3 then minus 0.3 and 0. The load diagram, I'll just draw the load diagram quickly and leave it for you to complete, and you'll see the load diagram shape is exactly like the one which we started off with today. A, B, we have not marked this point, then here is C and here is D. It's plus 0.3 and minus 0.3. From A, it goes to minus 0.3. From A, it goes to minus 0.3. Then it remains minus 0.3, becomes plus 0.3, remains plus 0.3 up to C, then becomes minus 0.3, minus 0.3 and 0. This is minus 0.3, this is plus 0.3, this is minus 0.3. Do you agree with the load diagram, guys?
Yes, sir.
And you see, this is the diagram I was talking about with it. Okay, this one. This was the load diagram. This was the question we did today, no? Yeah, so this was the question we did, right? You see, this question is exactly the same, only the values are different. The load diagram is exactly the same. You see, the load diagram is exactly the same, only thing is the values are different. Understood, beta?
Yes, sir.
Okay, so that load diagram and this load diagram is exactly identical. Instead of minus 5, that is minus 0.3. Instead of 20 meters, you have the 3 meters each. So only the spacing and the values have changed. Rest everything is here. So guys, can I take it that you'll be able to complete this question number 5? Yes or no?
Yes, sir.
Okay, so please complete this. Okay.
सर शुरू से 5 पॉइंट ले कर सकते हैं सर इसको?
हाँ 5 ले लो, कोई बात नहीं. No harm.
Okay.
Okay. As I said, if you take an extra point, no harm done, right?
ठीक है.
Okay. A box-shaped vessel 30 by 8 floats in seawater with ore. This we have just done, right? This we have just done. Okay. Let's look at this one then. A box-shaped vessel, 100 meter long, 15 meter broad, floating in fresh water at even keel draft of 5 meters, is then loaded with, so fresh water 5 meters is its light draft bit, and it is even keel. That means light displacement is uniformly distributed. So the light displacement of the vessel will be equal to 100 into 15 into 5 into freshwater 1. How much it becomes, beta? 7,500?
Yes, sir.
7,500 tons?
Yes, sir.
Okay. Is loaded with bulk cargo stored in 5 equal length holds. So 5 equal length holds. I don't think this is a question that we are going to do. 1 and 5 is same. 1,400. 1,400. 2 and 4 are 1,200. 1,200. 1,200. And this is 1,500. So you can total up the weight. It's 28 plus 24. How much it? How is the total weight of the cargo, beta? Cargo is how much?
6700.
Okay, 6700 tons. So the total displacement will give you the buoyancy 0, 0, 12, 1, 13, and 14,200 tons will be the buoyancy, if I'm not mistaken, beta. Yes or no?
Yes, sir.
And will the vessel be on even keel?
Yes, sir.
So it will be a straight like what? Yeah, so it will be a even keel with displacement buoyancy of 14,200. So it will be a horizontal line like yesterday. So it's a question based on yesterday's concept, which you might have attempted yesterday. Okay. Then a box-shaped vessel, 100 bulk cargo stored in 5 equal holds. Same question. Only thing is it is in fresh water, 6 meter draft. Weights have been changed. So same question, except the values changed. Okay, now we come to this one. A box-shaped vessel, 24 meter long and 6 meter wide, has light displacement of 24 by 6. Okay, let's make the 24 by 6 vessel. Has a light displacement of 120 tons. Iron ore of stowage factor 0.6 is loaded 3 meter high at the forward end and slope aft end and sloping to 0. So it is basically like this in this case. This is the cargo. Yes or no, beta? Draw the SFBM diagram. This height is 3 meters. This height is 3 meters. And this is 0 here. Height is 0, right? The cargo has no slope in the athwartship direction. Draw the SFBM diagram. Guys, do you want me to make the load table and leave it then? Shall we make the load table and load diagram so that it's revisited? Yes or no? Or you'll be able to do?
बना लेंगे सर.
बन जाएगा पक्का?
पक्का.
If anybody has any doubt, then get back. कर लेते हैं, चलो कर लो, कोई बात नहीं. Okay, now you only tell me, beta, how many points you think should we take? Look at the diagram and tell me.
3, sir.
3. अरे जिसने करने को बोला था वो उसको बोलने देना, ताकि he also revises. I want you to revise, beta. Okay.
सर डाउट है सर, ये जो लास्ट लाइन जो बोला है नोट में, द कार्गो हैज नो स्लोप इन द athwart डायरेक्शन.
हाँ, so ठीक है ना, that means the volume will be area multiplied by breadth ना.
अच्छा अच्छा.
Okay. Okay.
ठीक है सर, बनाते हैं सर, अगर कुछ डाउट होगा तो.
नहीं अभी कर लेते, कोई बात नहीं, somebody check कर लो. कोई इशू नहीं है बेटा, कोई I'm not in a hurry. कोई We can take A, B, C. Okay, we'll have to get the weight of the cargo beta first. Light displacement is known. What has he given us? A box-shaped vessel, light displacement given, stowage factor is floating. So now we have to get the weight of the cargo, okay? So the cargo weight will be equal to this area. So each length will be 12 meters, 12 meters. So it will be one triangle, that is half base into height area into the breadth 6 meters, that is volume of 1/2, multiplied by 2, to make for two triangular portions, two wedges. Divide by the stowage factor of 0.6. How much is the cargo weight, guys? How much is the cargo weight, beta?
$360 tons, sir.
360, is it?
Yes, sir.
Okay, so that gives us the buoyancy of 120 plus 360 equal to 480 tons. Distributed over 24 meters at the rate of 20 tons per meter buoyancy. Light displacement 120 divided by 24 will be 5 tons, 5 punch of these, 5 tons per meter, okay. And now we are good to get the thing. Guys, what is the weight of cargo at A? Cargo weight tons per meter at A. It will be the weight of cargo contained if the height of 3 meters is continued for 1 meter. Okay, so it will be height 3 meters, length 1 meter, breadth 0.6, volume, breadth 6, not 0.6, breadth 6. That becomes volume divided by the stowage factor of 0.6. So this becomes 10 on top. It is 30 tons per meter. Am I right, guys? Without calculator, you can get it. It's 30 tons per meter at A. Am I right? Just see. Or have I made a mistake?
Correct, sir. ठीक है, sir.
Okay. Okay. Now we are good to make the load table. I'll leave it load diagram. Okay. I'll make the load diagram and leave it so that people don't have confusion. Okay. We have only 3 points, so we'll finish up fast. Anybody who has a problem can please interject anytime, guys. You don't have to remain silent. This is light displacement. I'm not writing tons per meter and all that to save time. It will be 0, 5, 5, 5, 0. Cargo, tons per meter. Guys, to the left of A is 0. At A, suddenly it comes. So it will be divided. It will be divided. To the left of A, cargo is 0. To the right of A, or just to the right of A, is 30. Then it is 0, 30, 0. This becomes the total cargo, total weight. 0, 35, 5, 35, 0. Minus, 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 minus. Buoyancy 0, 20, 20, 20, 0. That takes us to load beta. These two need to be divided. 0. So this is plus, 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 plus. 0, minus 15, plus 15, minus 15, and 0. The load table load diagram would be like this beta. A, B, and C. Plus 15, minus 15. And load diagram will be slanting lines because the cargo is slanting. Okay, so you know that. From 0, it will go to minus 15 at A. It goes to minus 15. Then it goes to plus 15 at B with a straight line. Comes to minus 15 at C, becomes 0. It crosses at X and Y. They will be mid-length, so there will be 6 meters each. I think now you can close the question after this. After the after the load diagram, you can get the BM and SF and BM. Yes or no, beta? Correct?
Yes, sir.
Okay. So this is what we have just done. Okay. A box-shaped barge, 40-meter long, light displacement 160 tons, is loaded with 200 tons of cargo, peaking at mid-length, sloping uniformly to nil at the ends. This is exactly similar to the previous question that we have done. Light displacement is known. Load displacement loaded with 200 tons of cargo, that is also known. The stowage factor. Now, this question has been intentionally put here. Problem here is there is no stowage factor. There is no breadth of the ship. So please pay attention to this question. I think it was in one of the MMD questions. I've intentionally taken it here. A box-shaped vessel. Just be careful about this question, guys. Length 40 meters. Breadth not known. Displacement, light displacement 160 tons at the rate of uniformly distributed, that you can do. Is loaded with 200 tons of cargo, peaking at mid-length. So cargo is peaking at mid-length. We don't know what is the height, and sloping to 0. He says draw the SFBM diagram, guys. Problem here is the stowage factor of the cargo is not given. The breadth of the cargo is not given. How do I get the volume? Okay, the weight of the cargo is given. That's fine. So guys, in this case, don't worry, don't get panicky. So this question is especially only for the first part I need to do. What you need to do is how much is the weight at per unit length at B? That means how much is the, at A it is 0, at C it is 0, how much is the weight per unit length at B? Okay. So let's say what is the weight of the cargo? It will be the volume of the cargo. How much will that be? Half. Base is the length of the barge multiplied by height h, area of the triangle multiplied by the breadth, volume divided by stowage factor. This becomes the weight of the cargo, and this is given as 200 tons in the question. Okay, so this becomes 20, this becomes 100, no, this becomes 10, not 100, 10. Okay, this implies B is equal to 10 into SF upon H. Please, do you agree with this, that relationship? Please see that and let me know if there's any question, guys. B is equal to 10 into SF upon H, or whatever. You can write SF is equal to this or H equal to this, anything you can write. That's okay. Agreed, guys? This expression you are okay with? Any questions up to this point? Now we have to calculate weight of cargo in tons per meter at B. What will that be? What is the height of the cargo at B? H. So if this height H continues for a length of 1 meter over the entire breadth of the ship, is divided by stowage factor, this is the weight of the cargo per unit length at B, yes or no, beta? Do you agree with me? Please speak up. Do you agree with me? Weight of the cargo per unit length at B, H into 1 into B upon SF, yes or no?
Yes, sir.
We replace the value of B here from the above expression. So H into 1 upon stowage factor is from this formula, and B is given as 10 into stowage factor upon H. Now stowage factor and stowage factor gets cancelled. H and H gets cancelled. That means weight of the cargo at B is 10 tons per meter. Weight per unit length of cargo at B is 10 tons per meter, which you will use in the load table. This was the new thing to this question. This was the catch in this question, because suddenly you will say, how do I calculate height? You told us, okay, height is H multiplied by 1 meter multiplied by breadth divided by stowage factor. I don't know the breadth, I don't know H, I don't have the stowage factor. How do I get? So this is the way you will get the weight of cargo at B per unit length. So that is the difference. Once that is done, question becomes like any one that are the sloping ones that we have solved. It's like the first question once this 10 tons per meter is calculated. Is that clear, beta? Okay. So you can please remember this question. Don't get confused if it comes in the exams. Don't get unnecessarily trapped. It's a very simple one. Once you get this, then the question is like the first one that we did today with the sloping cargo. Okay. Guys, this is the one which came. Guys, if you have any doubts, you can ask me. Otherwise, before I do this question, you better take 5 minutes break. So 11:25, we resume. Others can ask their doubt now. During the break, no issues. And those who have understood can take a 5 minutes break. This question number 11, the last question, I start at 11:25. I digitize this question. Okay. A box-shaped barge, 32 meter long, 5 meter broad, is empty, afloat on even keel. It has, so empty on even keel means light displacement is uniformly distributed. It has 4 identical holds and its light displacement is 120 tons. Bulk cargo is then loaded and trimmed as follows. Number 1, 124 tons trimmed level. 2, 216, 134, 225. The final drafts are 4 and 6 meters. Draw the SF and BM diagram of this vessel. It came as late as July 22. It had never come before that. It first time came in July 22. Okay. Here is the vessel, 32 meter long. Guys, are you all back? Those who had gone for a break or something? Yeah, we can start. Breadth 5 meters. Has 4 holds, identical holds. Light displacement is 120 tons, 3.8 tons per meter. Okay. Cargo weights 124 tons, coming to 15.5 tons per meter. Beta, can you mute yourself? Can you mute yourself, please? Mute yourself, guys. 216 tons, 27 tons per meter. 134 tons, 16.8 tons per meter. 225 tons. I have rounded off that to 1 decimal place in this question, but everything. I'll be working rounding off to 1 decimal place only. Because in any case, I'm not going to get exact things, so might as well simplify the working. So guys, up to this, any questions on the diagram, read the question and tell me. And then the vessel is found to be floating at this water line. Please tell me, does the diagram relate to the question? Yes or no? Please read the question and tell me if the diagram relates to the question.
Yes, sir.
Okay. Now, then the points we choose will be obviously at the bulkheads, and also the cargo weights are changing there. Obviously. Now, guys, it is important to recall the definition of buoyancy. What is buoyancy? What is buoyancy, guys? How do you define buoyancy?
The upward force exerted by the water displaced.
Okay, it's the weight of the water displaced, right? It's the upthrust, and it's equal to the weight of the water displaced. Good. What will be the weight of the water displaced? It will be the volume of the water displaced multiplied by the density of the water. Am I right, guys? Weight of the water displaced will be volume multiplied by density of the water. Okay. Now, guys, tell me, when I say buoyancy per unit length, if I say buoyancy in tons per meter, what does it mean? That means it's the weight of water displaced per unit length. Length of how much? 1 meter. Now guys, the volume depends on what? What parameters does the underwater volume depend upon? Name the parameters, please. Underwater volume depends on which parameters, beta?
Length,
Length, breadth, and
draft.
draft. Very good.
Draft.
So here the breadth is the breadth of the ship. Length, because we are saying per meter, so length is 1 meter. That means in this case, what is changing? In all the questions we have done until now, the draft was same. So therefore we said buoyancy is uniformly distributed. Here also the total buoyancy will be equal to the total displacement of the ship, undoubtedly. But the buoyancy is not uniformly distributed. The after parts displace more water. So in those portions, the buoyancy per unit length will be more compared to the buoyancy in the forward region. Therefore, buoyancy per unit length at different points along the length will depend on something that is changing along the length. And what is changing along the length is the draft. So exactly like the weight of cargo, where the height was changing, and we said it is the weight of cargo over 1 meter length, assuming the height to be the same as the height at that particular point. So same thing. It is the buoyancy. If I say buoyancy at point B, that means what I mean is buoyancy for the draft corresponding to at B. That means weight of the water displaced, assuming that the draft at B was continued for 1 meter, whatever is the volume of water displaced, that will give you, and the weight of that volume will give you the buoyancy per unit length at B. So that means same draft at that point D continuing for 1 meter length over the breadth, this will be the water displaced, and the weight of this water will be the buoyancy at that point. Have you understood better what I've said? What is buoyancy per unit length? Because in this case, light displacement is uniformly distributed. Cargo weights are also uniformly distributed in the respective holds, but buoyancy is changing along the length of the vessel. So we'll have to basically, when you make the load table, the buoyancy values will have to be different at different points. That's what you'll have to keep in mind. Okay. So I'll show it to you again. I think up to the diagram, all of you were aligned with me. Now, up to this, we were aligned. Now, guys, what is the draft at E? Draft at E is 4 meters. What is the draft at A? Draft at A is 6 meters. Look at the diagram. What will be the draft at C then? What will be the draft at C?
5 meters.
Very good.
Main draft.
If C is 5 meter, A is 6 meters, what will be B? 5.5. And D?
5.5.
And, yeah, and D 4.5.
4.5.
Yeah, you can write like this, okay? Okay. Now, what will be the buoyancy per unit length at point A? This will be the weight of the water that will be displaced. If the draft of 6 meters is for 1 meter length, so it will be 6 meters draft, so 1 meter length into B, the breadth 5 meters, into 6 meters draft, that is the volume, multiplied by density, since it's seawater, if I believe, then multiplied by 1.025. Will this be the buoyancy per unit length at A? Please see and let me know if you have any question. Buoyancy in tons per meter at A will be draft 6 meters continues for 1 meter length over the entire breadth of 5 meters, that is the volume, multiplied by 1.025. Is that clear, beta? Clear, guys?
Yes, sir.
Exactly the same way, we can calculate buoyancy per unit length at B, C, D, E. Everything is same, only the drafts are being replaced. Everything is same, but the drafts are changing from 6 to 4, right? So buoyancy per unit length at these points changes from 30.8 tons per meter at A to 20.5 tons per meter at point E. Is this clear what has come on display, guys? If you have any questions, let me know. If you have understood this, then we are good to make the load table. If you have understood this, we are good to make the load table. We make the load table for 5 points A to E. Okay. For light displacement, it is 3.8 tons per meter written right on top beta. You can see 120 tons at 3.8 tons per meter. So A and E will be divided into 2. Nothing new about it. 0, 3.8, 3.8, 3.8, 3.8, 3.8. Everybody good with this entry, light displacement entry? Then the cargo is also not an issue. You already have dealt with. All the points will be divided into 2 parts. So 0, 28.1. All these, you can look at the diagram. The diagram is able to help you in filling up these cells. No change as far as what we learned yesterday about these 2 columns, 2 rows. This gives us the total weight acting downwards. We do the algebra, summation of these 2. We get these weights and we suffix them with minus sign. Guys, please see up to load W. I don't think there is any change from what we learned yesterday and should not be a problem. Is that clear, beta? Clear, guys?
Yes, sir.
Please see and let me know if you have any questions. Okay. Now we come to the important part, the buoyancy, which is not uniform, right? The buoyancy per unit length. Now, to the left of A is 0. Just to the right of A, the draft is 6 meters. It becomes 30.8. So we divide A and E into 2 parts. So 0, 30.8. At B, it is 28.2, 25.6, 23.1, 20.5, and 0. I have picked up these values from what we calculated here, guys. These values have come from here. Please look at the buoyancy and let me know if there is any question to ask. Okay. Then load is not an issue. We get the loads. Put the plus, 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 and now we get the load. I'll take a pause for you to check the loads and be happy with the load table first. Only new thing that has come is calculation of buoyancy per unit length at each of the stations because of the varying draft. Because of the varying draft. Clear, bachcho? Is that good, bete? Okay. Now, we make the load diagram. These are the 4 points. You can see them here. Our scale is up to 8. We have to go. Okay, then I've taken 3, 3 each, so 9 I've marked, plus 3, plus 6, plus 9. Based on the space, I've taken the biggest possible scale I could take. Then I plot these values, 0 and minus 1.1, and minus 3.7, then plus 7.6, then plus 0.5, then minus 5.2, 7.7, 1.2, sorry, 3.8, 1.2, and 0. Then from 0, I connected to minus 1.1. You can see it now being joined. 1.1 to 3.7, 3.7 to 7.6, then to 5, then minus 5.2, then minus 7.7, then plus 3.8, then plus 1.2, plus 0. And each of them is 8 meters. And these are the values I have put on the diagram. Guys, please see and tell me if you are satisfied with the load diagram or you have any questions. Guys, good up to load diagram, please let me know.
It's okay, sir.
Okay. Now, again, why they are slanting straight lines? Because the buoyancy line is slanting this time, not the cargo. Out of the three, the lightweight is horizontal, cargo weights horizontal, but buoyancy line slanting, and hence the resultant is slanting. Okay. Now we use this load diagram to make the buoyancy. Now guys, one thing before I go, I want to point out is, you see, basically, you see this trapezium and this trapezium. This side is 3.7, this is 3.8, this is 1.1, this is 1.2. These are actually same. They are coming because of the rounding off issues. Secondly, if you add the total weight of the cargo of the ship, light displacement plus cargo, and you calculate the displacement by law of flotation, that is length into breadth into draft of 5 meters, height draft into 1.025, you'll find there is a difference of 1 ton between the buoyancy and the displacement. That means drafts have also been rounded off. So drafts have been rounded off. We have also rounded off the values, and they are showing up as a difference in these two. Otherwise, I'm sure by looking at the diagram, you can see that these two areas should have been equal. So these values should have been actually same. They are changed. Likewise, these two areas, you see, this is 5, this is 5.2, this is 7.6, this is 7.6, 7.7, 7.6. Basically, these two areas are to be same and these are to be same. The slight variance that is coming is because of the rounding off issue. Have you understood better? You can see the diagram that positive areas and negative areas have to be equal in the load diagram, and therefore whatever is slight variance, that's a rounding off impact. I'm not deterred by that. I'll continue my working. In the end, what will happen? The SF will not become 0. There will be some small leftover, but I'll make it 0 because I know why that spillover has come. That spillover is because of the rounding off impact. So we go to here is the load diagram that we had in the last page. Same diagram has come here. This is area A1, this is area A2, this is area A3, this is area A4. I have not made any corrections. One way is I could have corrected these values, normalized, and then solved. But I said, let's not normalize, let them continue. Let's continue going with whatever has come. A1 area will be the area of the trapezium, half C on top, half into sum of the two sides multiplied by the distance between them. Is area A1 19.2 understood, guys, or anybody has any doubts? Area A1 I have calculated here. Are you good? Just see, it's area of the trapezium, right? Sum of the parallel sides multiplied by half the sum of the parallel sides multiplied by the distance between them, right? Can you confirm if area A1 is, you know this formula, right, beta? Trapezium? Okay.
Yes.
Likewise, I have calculated area A2, A3 and A4 based on the values which are there in our load diagram. Now using these areas, I'll make the SF table. So SF table by areas under the load diagram you see here now. We don't need any extra point because load diagram is not cutting at any extra point. So these points are good enough. And we get the SF. SF at A is 0. At B, first I carry forward 0. Change from A to B is minus area A1. So sorry, I wrote by mistake area A2. It is minus area A1. And minus area A1 will be minus 19.2. Is that correct, beta? So this is area A1. This is a typo error, beta. Do you agree? Is the shearing force at B going to be minus 19.2, guys? Yes or no?
Yes, sir.
I carry forward this minus 19.2. Change from B to C is plus A2. So I add 50.4 to it and I get a residual of plus 31.2. I carry forward this plus 31.2. The change is area A3 minus negative area A3. And that gives me minus 20.4. Then I carry forward this minus 20.4 and then I add plus area A4 and I get a residual of minus 0.04, which you know why it has come. And what have I done? I made it 0. Yes or no? Do you agree with the shearing force diagram, beta? Shearing force table rather, sorry.
Yes, sir.
You will not have any problems up to this point. You can draw your shearing force diagram also good or bad. Whatever problem would be there will be with the BM, because making BM 0 is going to be a huge challenge anyway. Okay. We draw the SF diagram. We have these points. Our SF values are up to minus 20 and plus 30. So I've graduated the scales. I put the values. Now look at the tables, beta. Now you see, guys, it is not exactly a triangle. It's basically a trapezium. Over 8 meters, the height changes by about 2 meters. About 2.5 something. Okay, so it will not be a straight line, agreed. But whether it will be closer to a straight line or curve, that depends on how much is the difference between the parallel sides. If the difference is too much, then it's going closer to a triangle. If difference is less, it is getting towards the horizontal line. And that means resultant will be nearing a straight slanting line. But anyway, it's not going to be a straight line come what may. So I join using the concept. It's a curve. It's not a straight line. Because I'm going from smaller to bigger one, first the rate is less, then the rate is peaking as I reach B. Then from B, if I look at the trapezium A2 area, it is from the bigger to smaller side. It will be greater first and then getting little lesser at the end. But not lesser does not mean lesser. It is still 5 meters, so it is not going to become horizontal. Why? Because the other side is not, other end, it is not becoming 0. You still have 5, right? The other two will be the counterparts of it actually. So exactly the mirror image of this I have done. This will be my shearing force diagram, beta. Now this shearing force diagram is cutting the x-axis at two more points, x and y. So that means for BM, I'll have to have 5 plus 2, 7 points now. I can put the values. Now the thing is, I will need this distance and this distance. Yes, I can calculate by quadratic equation the way we solved yesterday. Like this, we can solve here. But guys, it will really be confusing and take a lot of time. You saw yesterday also when we had to solve the quadratic equation minus b plus minus under root b square minus 4ac upon 2a. So I will not advise you, because this question is already becoming too lengthy. And if now we start calculating these points, it will really go out of control. Okay. So what I'm doing is, that's why I suggest take this x-axis as long as you can, so that you are able to get a large scale. And then I have used my scale to read these distances from the graph, and I have written it here. You see, from the diagram, B to X is 2.6. So X to C will be 2.8 minus 2.6. Likewise, D to Y is 2.6 and C to Y will be 8 minus 2.6. I had actually superimposed the graph over it and read it from the graph. And then I removed the graph just to give you a clear view on the white background. Okay. So this is what I have read from the graph, and that's what I would recommend to you also. Though mathematically it is calculable, but calculating it will again send you in circles. So go by your diagram, don't worry. If it comes as 2.4, take it 2.4. It comes 2.8, take 2.8. I'm sure when I draw this diagram again, I'm not going to get 2.6 again. I'm going to get something less or more. Okay. Okay, now in this diagram, guys, when you go to BM, so we put these values here before I go to the next page. In this SF diagram, now if you see, if the BM at E has to be 0, then what do you mean? That means this area should be equal to this much, yes or no, beta? This -1 and +2, this +3 and this -4. The other side is exactly mirror image. So that means these areas have to be equal or nearly equal. They cannot be exactly equal by the curve for sure. So you'll try to make them nearly equal and make them 0 as we did here. Is 0.4, we made it 0 here also, right? Now I'll take you to the BM of it. Now what have I done is, I have divided it into certain areas. Area 1, area 2, area 3, area 4, area 5 and area 6. I have divided this curve into 6 areas, beta, so that you can understand clearly how SF BM table is made. And then I have calculated these areas. A1 I have calculated by using Simpson's rule 141. You can see area A1 calculated here. And I'm sure you'll agree, A1 and A2 you will agree would be same. What have I done? 1/3 is the coefficient. If I take a middle thing here, read off this from the graph, and I get it 62.9 as area A1 by 141. A1 and A2 become 62.9. This A3 and A4 is nearly a triangle. So I have just cut short and taken it as a triangle because it's a small portion. So A3 and A4, half base is 2.6 from my graph and height is 19.2, and I get it 25. That is how I get these 4 areas. Area A5 and A6 will be same, and I have solved them again by Simpson's rule 1. One by 3 into common interval. Now X to C will be 5.48 minus 2.6 equal to 5.4. Half of 5.4 will be 2.7, guys. So I have taken midway here another ordinate. Come somewhere there. Okay. And I got these areas 89.3. Now getting these areas will be a challenge for you, I can tell you upfront. And that's why I digitized it, because otherwise it will unnecessarily lead to confusion. At least now you know the sequence of things that has happened. Now using these areas, I'll make the BM table. For how many points? 7 points. A, B, then X, then C, then Y, then D, and then E. BM will be in ton meter. At A, BM will be 0. At B, I carry forward the 0 from A to B. It is minus area A1, and A1 is 62.9. So minus 62.9 is the BM at B. I carry forward this minus 62.9, and to that you have minus area A3 getting added, minus A3, and that becomes minus 87.9. Then we carry forward this minus 87.9, and we have plus area A5. A5 is 89.3. It leaves you with plus 1.4, and what have I done? I have made it 0 here, guys. We know these are the errors in reading and rounding off on the graph which are leading to this residual thing. I carry forward this 0 now, and then I have area A6. This should have been area A6, guys, but A5 and 6 are same, so no problem. This will be plus 89.3. We carry forward this 89.3, and then we have minus area A4. A4 is 25, which leaves you with 64.3. Then you carry forward 64.3, and you have minus area A2, which leaves you with again plus 0.1, which is nearly 0. So I have made it again 0 here. The residual part I have knocked off in between also. Otherwise, it would have become plus 2.8 at the end. Then you will have to knock it off there. Okay. Now we come to the BM diagram based on the BM table. It's all, there are plus and minus both. So we have these points. Okay. These are the BM values. We have to go up to 90, 90. We put these values as per what is there. We put these values, we put these values. And then we look at A to B. It is vertex to base, and next is base to vertex. So at X, so it is going like this. It goes like this, beta. Why? Because this is vertex to base, then it is going towards the vertex, so it becomes little horizontalish, and then it is going from here, it starts picking up towards the end, so it goes like this. So this will be the curve from A to C, and from C to E will be exact replica of it, like this. And this will become the BM diagram for this particular question. Now, how much you will be comfortable with the BM, I will keep my fingers crossed, because getting the BM 0 again is always a challenge, especially because of the limitations of the graph and reading of the values. You'll have to force them to be 0 as you move along. And since the graph is used, here the values are also unlikely to match between your values and my values, because if you are reading differently from the graph, the values would change. But the shape of the graph should not change by and large. This will be the shape of the graph. The values, of course, will change from person to person, because you are using the values read off from your diagrams. So that is the limitation of this. In this question, usually I have seen people not struggling up to SF. Their problem, their pain starts when it comes from SF to BM. Okay. My suggestion to you would be that if such a question comes, firstly, chances are they repeat this question. So if they repeat this question, you can carry some of these values with you, not on the sheet, but in your brain and mind, okay? And see if you can reproduce them. Otherwise, with shape will be fundamentally this only, because even if somebody has to set another question, if I have to set the paper, I'm not going to text myself bloody with a trim question and unnecessarily texting myself, drawing the graph, getting the values, and then fighting for it. So believe me, in all probability, if it happens, the question is likely to be repeated if at all it comes again. That's my gut feeling. Because anybody who sets the paper with new values of trim and everything will have to again sit with his things, and he'll also have to draw the things to get these things, which is not an easy task. So yesterday, that's why I said, if I do it in hand, there'll be a lot of confusion. So I said, let me digitize this question so that it goes in a systematic way. What I can do is I can clear off everything and give you an opportunity to take a screenshot of the 3 slides, maybe that you can go through, and that will close your question of this. And since it has come in the exam, guys, please don't leave it unattended. Don't leave it unattended. Since it has come in the exam, you should not be just, caught unawares. So okay, let me just remove this 1.1. Why it's coming here? I don't know. Must have been doing something. And one more change was to be made. No, so somewhere I think here it was to be made. It was to be A1. Guys, would you like to take the screenshot of this one once I complete show up the full information here? Would you like to take a screenshot, guys, now?
Got it, sir. Already got the screenshot.
Okay, take the neat one because I must have scribbled something. If you want to take without my handwritten stuff on it. Okay, next. You can take it if you so desire, beta. Then we come to here. This is A6, guys. This one is A6, okay. Okay, these are the values. You can put these values here, beta, if you want. This will be at X, it is minus 87.9 plus 89.3 plus 64.3, then 0, and then plus 62.9. These little bit changes, differences between the two maximum values are because of the rounding of issues, nothing else. Otherwise, they would be exactly the same. So you can go through this. This addresses the trim issue. You can see the graph there. I have kept a graph paper here. I had actually read it from the graph. So this is the graph I had superimposed to read these values, guys. So they are not just put for the sake of putting here. It was aligned here. And this is how it was basically read off. This is how it was read. And you can see from the graph, these values nearly coming that. This, if you align with B, and C. You have 25 units, 25 small squares representing 8 meters. Then you have about 8 small squares here. They represent 2.6 meters. So it is basically 25 squares representing 8 meters. 1 upon 25 into 8. This comes to about 2.6 or whatever. That's how this value has been calculated. Okay. So this is not some randomly put thing. They have all been made to size and scale. And that's how these values have been put, just to put your curiosity to rest. It's not something just for the sake of matching the values. They have been picked up from the graph actually. Okay. Now, any questions that you would like to ask on this? I know you will not have many questions to ask. Questions I've already shared with you. Tell me, guys, if you have any doubts. With this was the last question on my agenda, beta. Now it will be for you to close out the topic and come back with your doubts. From my side, your SFBM is closed. If you have anything to clarify or ask or discuss, let me know. Is that okay, beta?
Yes, sir.
Okay. Please revise these questions that I have sent you. Do those questions. Pray that you don't get this trim one, which in all probability you will not get. Probability is very, very low. But please be mentally prepared if it comes. If nothing else, at least do up to SF. Make the BM table, do something, and don't leave the question unattended. Okay, so you should be able to do the question to whatever best you can. And I'm warning you upfront, you will have challenges in solving this question. So be prepared. So don't get suddenly worried that, oh, this question has come now. I don't know how sir drew it. I'm not getting it. You will have challenges. Be prepared for them. Don't unnecessarily get bothered. Just continue, keep your cool, and do whatever best you can get out of this. Up to SF diagram, you should be able to get. For BM, also try to manipulate a little bit diagram here and there and get the answers and get the BM at both the ends 0. Okay. Okay, guys.
Yes, sir.
I can't say anything more than that on this particular method.
Okay.
Why they have to put it for students to manually calculate, God only knows. So it's up to people who are doing it. Anyway, so your moment of inertia applications completed, bilging completed, SFBM completed, all from my side, subject to taking doubts. You're always open to take up the doubts, guys. That's not an issue. You can solve them. Tomorrow, I plan to take minimum 2 topics, minimum 2. One is inclining experiment and other is heel during turn. Okay, so those will be the 2 topics tomorrow. If time permits, if we can squeeze in a formula only, that will help. So I'll see how we are placed tomorrow, because I'll try my best that whatever is important, I am able to do it tomorrow and day after. So 25th, 26th, today is 25th, am I right, beta?
24, sir.
Today is 20, okay. So 25th, 26th. So 27th, not much is left. Okay, so on 27th, for sure, if everything goes as per plans, I'll release you. I'll try to even see if I can somehow release you on 26th itself, so that you are left with ample time to revise and get back with your doubts. Okay. So see you tomorrow, guys, at 9:30. Let's start at 9:35 sharp, beta, so that we are able to meet our targets, and if we can save a day, why not? Okay. So
Yes.
let's not delay the starting.
Thank
Okay,
you, sir.
guys, if
Sir,
it's okay with you, yeah, tell me.
सर एक हैंडशिप का डाउट है सर थोड़ा सा।
हाँ बोलो बेटा, बोलो। ग्रुप डाल दो या पढ़ोगे? व्हाट विल यू डू?
सर मैं ग्रुप में फोटो डाल देता हूँ।
डाल दो। I'll take from the group and I'll take it on the slides.